Okay, welcome to Physics Today, everybody. We're right here. Number 3, vector components are independent. Number 2, notes. Okay, so we're going to take a few notes today. This is pretty easy stuff, but what we need to do now is concentrate on the vector being independent. Okay, and so what I'm saying is the x and the y stuff during free fall are independent from each other. Okay, keep in mind that we spelled time with a y because usually we figure out how much time something has to move in the x direction according to how much time it has dictated by the gravity. Because if there's no gravity, if I started throwing something, Newton's first law says things tend to maintain their state of motion, which would mean if I threw something straight here, and there was no gravity, it would just keep going straight forever and ever and ever. Go out of our atmosphere, out into space, and just keep going straight. But we have gravity, the force of gravity caused by this huge mass, which starts to accelerate it downward. So, depending on how much time it takes to fall, keep in mind that this falls just as fast as that falls, just as fast as this falls. The y stuff tells us how much time we have to go in the x direction. Okay, so this stuff is really pretty simple. A ball is thrown with a velocity of 22.5 meters per second, 23 degrees above the horizon. What are the vertical and horizontal components? I mean, that's, just flat out review. You can do that pretty easily, right? Vertical, horizontal, those two components. Almost everybody already got A's on that in the test, okay? Kind of a little review for doing the angles. I'm sure you know how to do that. Let's see if we can do this problem here, though. Okay, here's a little problem for you. It says a boat is traveling north directly across a river that is 5 kilometers across. The current is to the east at 3 kilometers per hour. The boat can travel at 5 kilometers per hour at top speed. What is the resultant velocity? In what direction is the boat traveling? How long does it take to cross, and how far down the bank does it drift before it reaches the far side? So I want you guys to try to do that on your piece of paper and see if you can come up with the right solution. Here's the picture I came up with right down here. So you can see that the little boat is right here, and there's that velocity vector here. Here's the velocity of the river. You got to put those two together. Okay, so I said this is pretty simple stuff you can do in your head even. I'm not sure about that, but let me ask you, what does this have to do with projectile motion? Can someone answer that question first? So the current kind of acts like gravity in this situation. Okay, so what does that say about the speed of the boat and how much time it takes to cross the river? The answer was it will be longer than an hour because it's not going straight across. But as I look at this, I see that the boat has a top speed which is going to be directed straight across the water. Do you agree? Because if you look at this vector here, that's straight across. And that's 5 kilometers every hour in that direction. Do you agree with that? Now, if we understand that this vector is independent from that vector, and the boat, stays aimed in that direction, and it's 5 kilometers across, how much time do you think it's going to take to cross the river? Okay, so if we're still maintaining this understanding that these two are independent, then I can say how far down the bank. Well, I know it's going to take an hour for me to get across the river, right? So that means I have an hour to go in this direction. Well, it's 3 kilometers an hour, so I'm going to be able to go, I should be going 3 kilometers downstream before I hit the bank. Do you agree with that? And the next question is, what's the resultant velocity? Let me, a squared plus b squared equals c squared. And we've got an answer of 5.8 kilometers an hour. And the direction then, if you do the inverse tangent, would be 31 degrees east of north. Is that what you guys got? Okay. As I look at my notes here, there's a mistake. What we explained was correct, but my notes didn't say that. So this should be 5,000 meters, which would equal 1 hour. So, kind of like normal, if I start putting things down on paper instead of doing my head, I screw up more often. And then that would change this too. This would be 3. Instead of 0.1 hours here, it should be 1 hour, like I just said. Oops. 1 hour, and then so if we have 1 hour instead of 0.1 hours, this would be 3 kilometers downstream. So I had a little decimal problem there myself. Okay, let's try another one here. Okay, so this question. So this question says a ball has a velocity in the x of 12.5 meters per second and a velocity in the y of 6.25 meters per second. What is the actual velocity and what is the angle of elevation? Okay, this is really kind of a review question here too. So as long as I didn't make any math errors here, you would come up with an answer that's close. I rounded quite a bit here, but 14 meters per second at 30 degrees above the horizon is how we would say this. Although it does say the angle of elevation here already, so you don't really need to say above the horizon because it's already given in the question. Any questions about that? Yeah, the angle is really off, but 26.57 rounds to 30. This would be a better number for you. Okay, so now we're looking at something that we are doing right now. Okay, so let's see if you guys can figure this out. I'm pretty sure you can. Ball rolls across the table at a constant speed of 4.5 meters per second, then rolls off the edge. How far does it travel from the edge of the table if the height is 1.25 meters? Okay, so this is really something you've already done. First figure out how long it will be engaged in the 4.5 meters per second in the x direction. So we had about 5.5 seconds, or 5.051 seconds. Is that pretty close to what you guys got? Okay, good. I'm not going to have to change that one. And then you just multiply that by the x velocity, and you get... Okay, so this is not quite right. It should be something like 2.27 meters away from the edge of the table. Okay, here's one more question here for you. If you guys want to try to put this together. Okay, let's reveal the answer. It may be right, it may be wrong. But what we got here was 30. I have a feeling this one's right because I wrote it. 32.3 kilometers at 86.6 degrees north of west. Is that what you guys got? So the question is, where did I get the 45? And we've just talked about this kind of briefly, but this would be your 0 point, 0 degrees. And as you go around, if this is the axis here, this would be 90, this would be 180, 270, and then 360, and 0 are the same. So when it says 135 degrees, that would be over here, which ends up being 45 degree angle. And that's where I got that 45. Okay, well it's going to be ended on a strong note there. I actually got one right on the notes.